Hello, this section is entitled Security, Know How to Use Network Policies. Before we get into this, I wanted to take a quick sidebar into being able to build your own custom images and then store them in Elastic ECR, which is Elastic Container Repository, right? So far we've just been using images that have been available public through the public Docker Hub, right? But in this case, we wanted to create. We're going to want to create a custom example that that deploys, in this case, a Python Flask application that's backed by a Redis database, which means custom code, and the code itself. So, see, here we go here. The code itself is not the point of this video, so I'm not going to really get into it. We're going to treat it like a black box. There's an app folder that has the code, right? And this is a Python project. So the main code is in main py FYI, and the pip file, lock, and the requirements. These are all about dependency management. And so again, there's some code. It's not terribly long. It just provides a couple endpoints, and I want to treat it as really as a black box. Related to that is a Docker file that actually builds the Docker image from the app, right? And again, I'm not going to really get into the details. Well, it's not much here, but I don't want to get into the details of that. I do want to show you, though, how to treat that as a black box and build an image out of it. So what you're going to do is, if you go to, I have to get logged in my AWS console. The good news is that the instructions are all provided to you by AWS. So when you go to here to ECR, Elastic Container Registry. Okay, what you do is you just create a repository. It's basically just give it a name. I called mine To-Dos because this is a To-Dos app, right? And right up here to the right, they actually give you instructions on how to basically build your image and then push it to this repository, right? So the first thing you need to do, just in general, you need to log in. This basically authenticates your Docker to AWS, right? In this case, I happen to name my project. We basically built it To-Dos, right, in the current folder. So you would run this command right in this folder here with the Docker file in it. That'll produce an image. You basically have to tag it in a certain fashion, and then you push it to the repository, right? So tagging is local, then you're pushing it to the repository itself, or registry, I think they're calling it. Now, in addition to this, because we want to use named or numbered tags like 0.1.0, just in addition for this article here, I actually ran two other commands. So the first I did was after I did those steps, I tagged the latest one with a name like this, the registry name, right? And then with a tag name of 0.10, and then I pushed that tag up. And then if you look here carefully at the registry, you'll notice that now the single image is tagged both with latest and 0.10. So now I can refer to particular versions of this application. Okay, so that's kind of the sidebar, right? And we'll use this image. Oh, and by the way, if you use EKS and it's properly configured, it automatically has read access to the registry, so you don't have to do anything special there. You just got to refer to it by the long URL name. Okay. So that's the sidebar. Okay, so the real content of this is called network policies, and so far, if you think about it, any pod that we've created can communicate with any other pod in our cluster, right? Because they use their pod IP addresses and doesn't really care about namespaces. It's just IP addresses at that point, and traffic just starts flowing, right? And you can also take those pods and just expose them to any load balancer. There's no rule saying, other than you just create the load balancer, boom, the traffic's there. Okay, so this pattern of just sort of an open, squishy, internal, right, is not necessarily consistent with securing a multi-tier application. So if you were doing stuff on Amazon, separate outside of Kubernetes, you would have learned about, creating different subnets, and then in those subnets you would create, essentially like a private subnet, a public subnet, and then you would use security groups to start securing down all of your resources, right? Or in this case, you would be using EC2 instances, right? So we're going to follow that same general pattern here, but in the context of Kubernetes, right? So let's imagine, first we're going to approach this from a conceptual standpoint, and this diagram will help us understand that. And then we'll figure out how to implement the logic, the logic here using something called network policies. Okay, but I want to have you have in your head at least what we're striving for. Okay, so the idea here is, imagine that you have a group of pods, and I'm kind of hinting at this. I'm going to put them all in the same namespace. So they're sort of conceptually grouped by namespace, right? So these are the production pods, right? And then additionally, I want to create these separate sections or separate tiers, right? Two different tiers within production, right? I want to create one called the logic tier and one calling it the data tier. The actual word networking logic will make sense shortly, but conceptually I've got, a bunch of pods that are production, and they're grouped into two parts. There's the logic ones and the data ones, right? In this case, I have, in my logic tier, right, I'm going to have a pod that's running or pods for that matter, running my Flask application, right? That's providing the APIs. And then just for, ignore this in Ubuntu for a second. And then in the data tier, I have a Redis, which is a database, and running in my data tier, right? And then for troubleshooting or for illustrating, the whole point of this, exercise is talking about controlling access. I'm going to put an Ubuntu image or container or pod in my logic tier, and I'm going to put one that's outside of my logic tier. So I'm going to just dump it into a completely different namespace floating way over here, right? And what we're going to do is we're going to observe, if we do things right, just the hint here is that if you look ahead, you're going to be able to access the database, Redis, from the Ubuntu that's in the logic tier, but not from the one that's in the personal tier. You will not be able to see this Redis database. That's going to be the proof that this is working, right? Now, what all these other diagrams mean, so let's see if I've got it bulleted down here, right? So let's kind of make sure I got all the pieces. So there's a logic tier, which we talked about, data tier. Okay, so some of the rules here is, okay. So so far those are the tiers, but the rules that we're going to try to apply to this conceptual logic is that this Redis database is going to only be accessible by the pods that are in this logic tier. So, which means this Ubuntu will not be able to see this Redis database. And that's what this arrow represents. Basically, all this means is that the only thing that this pod can be reachable is only by the Redis API or Redis port, and only from the logic tier is what this tries to represent. Now, this the other diagrams here will make more sense, but the first one is pretty clear. I want to have the logic tier, the Flask application. I want that to be generally available. I want my load balancer to get to it. Once it's externally available, it means it's publicly available. So what this means is that from anywhere, that's why this doesn't terminate anything, from anywhere I can get into these pods with HTTP, but nothing else. So if I was using HTTPS right now, I can't get into this. Or if I use Secure Shell to try to get through here, I can't. The only thing that's allowed into the logic tier is HTTP. And this none is, this will make more sense when we go down later in the diagram. This none is, just so you know, it's pointing at this namespace, and it's well, I don't want to get into it right now, but it'll make sense like when we go down to the implementation section. Okay. Okay, so now the question is, what are these tier thingies, right? We haven't talked about tiers. We know namespaces, but not tiers. So actually the implementation here is pretty much, well, how do we group pods in the world of Kubernetes? We use namespaces and or labels. That's the whole point, right? So in this case, we'll find out that the logic tier, right here, is basically a combination of any pod that's in the production namespace that happens to have the label with a key value of networking logic and the value of quote unquote true, just a string true. And then likewise, anything that's in the data tier is anything with a production namespace with a key value of networking data and the value of the string true. Now, one clarification, and I think I saw it some of the docs. These labels, the values need to be strings. So when I say true here, I put it in quotes because that makes it a string that's true. If I just put true, that's a Boolean true. And apparently that I don't think that works based on the docs. So you'll see in my code that when I create these labels, true is actually quote unquote true. Okay. Okay, so that's how we're going to create these tiers with labels and namespaces. Okay, so now what we're going to do here is let's look at this in play first. Before we look at the logic of how the network policies work, right, which we're going to talk about, let's look to see how these labels are being used in this project, right? So let me go, let's look at templates. Okay, so you see there's a lot of templates here now. Okay, so let's dive into the first ones. So let's look at the logic tier. So what I'm going to be looking at here is the Flask application. So there's two Flask things, right? There's a deployment and there's a service. Okay, so let's look at that. So the deployment itself, right? The key here is this is a regular deployment, just like we would normally do. This is where I'm using, by the way, you're going to have to change this if you're going to, this is pointing at my image, right? So you don't have access to my image, so you would have to do this yourself, right? But this is saying use that custom image, right? Hidden in here, by the way, is an environment variable, right? Redis, right? And so this is telling that container there where to find its Redis database, and it's going to live on the domain name redis-dev in this case, because this will resolve the dev, right? So this is basically just setting up that Flask container to actually run and see its Redis database. Now, I did set up a readiness probe too from earlier, just because this is just checking to make sure that this pod won't come up unless the Redis database is up. Okay, so this is kind of old news here. The new news is one line, this one line right here, right? So, or two lines. One, it's in the namespace production dash, in this case it'll be dev, and this one label right here is essentially how we're telling this set of pods that they're in the logic tier, because I applied this tag, and you notice the double quotes. Okay, a lot of conversation around the fact that there's one label on this thing, right? And then the same deal applies for my Redis. So I have my Redis deployment, right? And you'll notice that here, the key thing here is I've got networking data true. This is essential, and it's in the namespace production, somewhere up here. Okay, those two things are what make this now in the quote-unquote data tier, right? Okay, so that's all there is to those. And then, of course, I have my my Ubuntu instances. So my Ubuntu one here, I dropped this pod into the namespace production, and I put it in the logic tier. Other one is just floating around in a completely different namespace, and there's no labels having to do with the networking side of it. Now, one thing I didn't mention, that you notice I named these labels networking/logic. This is completely arbitrary. It's just any label, and it doesn't need to be true, doesn't need to be networking in it, right? I just saw some examples other people did, and this seems to be the pattern they used, where they prefixed it with networking, to indicate this is a label that has to do with network policies, and then true just because you needed some value, right? So this is completely arbitrary, but it seems to be a convenient pattern. Okay. Long story short, that's essentially describing how we've used labels and namespaces to group these pods into these tiers. Okay. Now, we haven't done anything other than just put labels on, so nothing's actually happening yet. Okay. The next thing we actually had to do was, out of the box, EKS does not support, like if you don't do anything, does not support these network policies, right? So what you can do is you create these policy objects and nothing actually happens. They don't get, and there's no rules get applied, right? And that's because doesn't, out of the box doesn't support it. Now the way that you support it is there's a project called Calico, right? Which essentially is designed to implement, basically network segmentation where you can control access between pods, right? That's essentially what we're doing. And now, and there's instructions here, if you click on this, there's instructions on installing Calico into Amazon EKS. It's written by Amazon and it works fine. It takes only seconds to do. One point of clarification, if you remember from a long time ago, we actually used something called Calico when we were installing our own cluster, and that was providing this, the CNI interface, which was basically all the pod networking, right? That is a separate, that's a related project, but that's the full implementation of Calico. What we're actually implementing is just the network policies part of it that's integrated into Amazon's CNI pod networking. So that's why if you follow the instructions here, you notice you're not installing Calico directly. You're installing an integration to Calico provided by EKS. So that's a point of clarification. But with that in place, now you can start writing your policies. Okay, so the first thing you need to understand about how, once you turn on network policies itself, nothing actually happens. So nothing special happens. It just has it ready to go, so when you write policies, they actually do something, right? So the first concept you need to understand is this concept of isolated versus non-isolated pods. So now, in your mind, you should be thinking of these terms in the terms of egress and ingress separately. So you can have a pod that is isolated for ingress, but not isolated for egress. So you need to kind of split your brain on that. And in this video, we're only going to be talking about ingress rules, right? So for all practical purposes, all of our pods can do anything on the egress. We're not going to, they're going to be non-isolated from the egress perspective. Only from ingress are we going to apply the logic to make them isolated. And that's pretty common. I mean, mostly when you're worried about protecting your network, you're usually first worried about who can get in, less about who can get out. Right? So okay, so we're only going to talk about ingress. Okay, and I think the easy way of seeing this idea. So the question is, what makes a pod isolated versus non-isolated? So it's actually, all it means is, what we're going to do is, shortly, we're going to create things called network policies, and they target pods based on labels and namespaces, right? And give me a minute. I got someone here for a minute. I'll be back in a few minutes. Okay, I'm back. What were we talking about? So again, the idea of isolated versus non-isolated is, again, if any of the rules, which are like targeting pods, apply to that pod, then it's immediately called isolated. If no rules match it, again, we're just labels and namespaces, then they're non-isolated, which means by default, if they're not isolated, any traffic can get into it. The moment any rule applies, they become isolated, and it kind of flips. Basically starts with, so what happens is when you have a pod that's not isolated, the default starting point is open access. The moment you have any rule apply, the default starting point inverses, and it starts off with the idea you don't have any access, nothing will flow through it until you open up access. So that's a tricky thing. You can go from completely isolated to not isolated in like one rule. And it completely, the moment you remove your last rule, you went from completely locked down to completely open. So that's one bit of trickiness around this. Now, the first thing we're going to do is, let's look by example, I think, is what we're going to do. We're going to basically lock down. So if you look at our diagram here, that's where this none business comes in. We're going to apply a rule that actually is like a non-rule. It just says target all of the pods in production, right, with an ingress. So it goes to only ingress, right, and that's why it's pointing in, with an ingress rule, but we're not going to actually supply any rules. So all that really does is convert any pod that's in production from being non-isolated into isolated. So now their starting point is you have no access. And then what we're going to do is we're going to create other rules to start opening up ports. So that's the first sort of default we're going to apply on all pods in production. And you can see that by example. This is where the any, I really struggle with the names of these files. And I'm not going to go through the logic of it, but it almost makes sense, right? So what this policy is here is, the key here is it's in a namespace, production -dev, right? So this is a target any pod. That's this rule basically means that any pod that in this namespace is going to be at least starting the target, right? And this pod selector, this is essentially the way that they designate empty, which is interesting pattern, but it's an empty object, I guess. So the pod selector is essentially empty, which basically implies in this case, an empty pod selector means all pods, right? And we're targeting as an ingress rule, but we're not actually, normally have rules down here, but there's no rules. So this is basically saying, select all the pods and put an ingress start off with an empty set of ingress rules, which then converts them to being isolated. So then they're all basically unavailable all of a sudden. You can't do no traffic can flow into these pods. So that's what this essentially does, okay? Which is somewhat counterintuitive, but that's how that works. So in the diagram, we just created this bottom thing. So at that point, nothing is accessible. And then we're going to create two more rules to open up traffic for two of these tiers, okay? So let's see if I have let me go back to my article here. Okay, so that's what this first section is. So we want to first open up our data tier, right? And yeah, so that's basically, that's going to be this arrow right here. Let's see what file this is. That is going to be data. I think I named these a way that I can figure this thing out. So this is basically, it's named data because it applies to the data tier, right? And it's from the logic tier, and it's an opening up Redis. That's how the name of this reads. Again, the name is not important, but it was the way to keep track of this. So the key here is, this is again only for pods in the namespace production. Here's your pod selector. This is going to apply to any pods that are in the data tier, which means they're both production and they have this label of networking data. So what this is, in terms of that diagram, this is targeting any pod that's in this thing, right? In this case, our Redis will be there, okay? And, okay, so that's how you're targeting the pods. This is an ingress rule, and now we're actually giving it an ingress rule, right? So here we're saying any traffic from the pods that are from the logic layer, right? Allow ports 6379, which is the Redis port. And again, in terms of our diagram, that now says any pod that matches these pods, right, can now pass traffic into this pod on the Redis port. Okay, so that's the first one. And the second one is, let's see, what is the second one? Is this other rule right here, HTTP. That's the third rule. And this one is opening up the logic tier. Let's look at that one real quick. Okay, so that one is logic from any. Okay, so again, this is in the namespace production, and this is selecting anything that matches the label of networking logic, which is any pod that's in the logic tier, right? It's an ingress, and I'm opening up port 80. And in terms of that diagram, that's essentially what you see visually here, right? From anywhere, I'm allowing port 80, which is HTTP, into that pod, that networking tier. Okay, so that is, by example, we created essentially three network policies, and I guess I kind of breezed over it, but these were indeed network policy objects, right? Um, and then the next step is we're going to run this and validate and kind of explore it a little bit. So I'm going to pause the video for a second. Okay, I'm back. Okay, so what we need to do is we need to validate the solution here. Actually, I have to actually run it, I guess, first. So helm ls helm get nodes, make sure everything's get nodes, and then make sure my environment's all ready to go. Got to clean. Okay, I'm running my node. Okay, I'm only running one node, but that's fine. So if I do helm install dev policies, okay, deployed everything. So kube control get all. Okay, so first of all, you notice I don't see anything if I get all. It's because I'm in the namespace of production-dev. That should be, so it looks like things are still creating, right? So I've got my, what do I have here? I've got my Redis deployment, Flask deployment, and I've got my services, right? And Redis is running as a cluster IP, so it's internal, and then I'm load balancing the Flask app so I can actually get it outside, okay? Let's make sure these are all stable. Okay, everything's running. Everything looks good from this perspective. I also ran something in the personal dev. I believe I have a pod sitting there. Okay, so that's, everything is running. That basically is showing that everything is running here. And then the last piece of this is let's make sure, this will take a minute or two. I also did a load balancer, so I should be able to go to EC2, and it probably is not up yet. If I go to EC2, under my load balancers, I think this is a classic load balancer, right? So this is internet facing, and the instances, it's probably still out of service. So this will take a minute or two, so I'm going to wait until this shows in service, and then we're going to start poking around and do some validation. Okay, we're back. So I just want to make sure this load balancer came back up. So this is the load balancer, and there's my instances, and you can see that they're in service. Okay, so the first thing I'm going to do is validate that we can, so the end-to-end test is, can I access the logic layer, right, through the load balancer, right, and hit the endpoint that then talks to the Redis database to return back some data. And in this particular example, again, it's kind of a black box, but in this example, there's an endpoint called slash to-dos. And if it's working, it should return back an empty set of to-dos. If it returned an error here, then you would know that something's not right. Okay. So again, there's endpoints for creating to-dos and deleting to-dos. That's really outside the scope of this. So this is my quick check. I think there's also a probe endpoint. Let's see if I can. Right, and then the probe basically just makes a call to Redis, and if it comes back with success, it means it actually talked to Redis. Okay, so that is validating that it works. Now, it's not terribly interesting because this actually, it working is not, it doesn't prove that that network policies are actually doing something. It just proves, I mean, I could have done this without network policies, right? Network policies are about prohibiting something from working, right? Now, the fact that this is working means I didn't overshoot and lock things down too much, right? So the next thing I'm going to do is we're going to log in, and we're going to, let me go back to this diagram, sort of just to illustrate the policies working. I'm first going to log into this Ubuntu container here that's in the logic layer. I'm going to connect to Redis, and I'm going to see it's going to work. I'm going to do the exact same thing from this Ubuntu container, same exact scenario, try to connect to Redis, and we're going to notice that it is not going to work. And that basically will sort of prove out that this policy on Redis is actually doing something, right? So let's see if I can quickly get this up and running. Okay, so kube control get all. What namespace is this? This is the production I'm just getting this so I get my bearings here. So my bearings are that I need to connect to the Ubuntu dev. Okay, so I need to kube control exec Ubuntu dev namespace production dash dev interactive terminal bash. Oof. Okay, so this one is in the production dev, and I have to get update, have to quickly install. In order to test Redis, I need to install a Redis client. So let's do this real quick. Update. So notice all my outbound traffic's working fine, right? Okay. So hang on, what am I doing here? Apt get install Redis tools. I think that's it. Yep. Apt get install DNS utils. I think that's it. Yeah. Okay. So those are the two sets of tools I want to do. So first I want to validate DNS. So if I do ns lookup, and the services are called, I think it's Redis dash dev, right? And of course the full name is, well, so this is under production.dev. Okay, so this is the container. Again, I'm inside of the Ubuntu that's inside the network. So if I do Redis, right, and then Redis client to the URL Redis, I can do Redis. To be consistent, I'll do the full name, right? Production. Okay, so I connected to Redis, didn't give me an error, and I can see the keys, which right now there are none, but I'm actually successfully connected. Okay, so now for comparison, I'm going to do this exact same thing from my other container. So let me but I want to, instead of production dev, I'm going to personal dev. So this is my container that's outside the logic layer. Doing the exact same thing here. Apt get install DNS utils, yes. Apt get install Redis tools. Okay, so let's check out DNS first. So ns lookup Redis dev. This should not work, right? Right. That's because I have to give. It's in the production dash dev. This should work, right? So that worked. So I'm going to connect to. Then I'm going to use Redis CLI URL Redis : Redis dash dev dot production dash dev. And if all works right, this will not connect, because this is not in the logic tier, which means it has no access. The traffic is basically being blocked. And that's exactly what we're seeing. Okay, so that's essentially the proof that something happened, and in this case, I'm not allowing Redis traffic in from anything but the logic tier. Okay, I believe that is right. So that's basically valid. I mean, it's kind of a weak validation. I mean, but anyway, we've just validated essentially that this rule is actually working, because we're able to successfully from Ubuntu get in here, but not here. Okay, I'm going to leave it at that. Now, the only other thing here I was going to cover, I'm not going to do it by example, but we looked at an example where you're always applying rules to pods. So you're always first matching the pods by labels and that, right? So that's what pods you're applying the rule to, right? But then the rules themselves, like for example the ingress rules, right? Those you can target different things. So we just did an example of a pod selector. If you look at that example, I guess I can look at it here. This right here, this pod, this was, not this one. I want to look at this one. More interesting is this one right here. So we have a pod selector here, right? And so you're always selecting pods up here based on labels. Here, under the what's the source of the traffic, pod selector says select pods in the same namespace with these labels. Okay, so that's what pod selector does. There's another way of doing this. We didn't do this, but you can use what's called a namespace selector. And this one will say match any pods in a namespace that matches this namespace selector. And what you do is you actually create tags on namespaces themselves. It allows you to group namespaces. And then you can say any namespace with this label, pick it, and then any pod is allowed to match this rule. So we didn't do that example, but that's what a namespace selector, again, the labels here apply to the namespaces. And once you pick a namespace, it picks all the pods in that namespace. And then there's a tricky one where you can actually combine these two, pod selector and namespace selector, in the same rule, right? And then you give both, in which case it's going to first say, pick any pod in the namespace that also matches the pod selector. So it's an and, right? And then the last one is an IP block. And this is kind of different than the previous three. You provide an IP block and says, hey, allow any traffic from this IP block. And of course, remember, because pods are ephemeral, you don't want to be referring, these IPs generally are not referring to pods. They're going to be referring things outside of your Kubernetes cluster. So that's it. Thank you.